Welcome back. This is Math Expert video tutorials. Now, in this video, we are moving to another interesting part under this course, trigonometry, and that is inverse circular functions. Now, under this whole inverse circular functions, we will be looking at first inverse circular functions, then we move to inverse sine functions, then we move to inverse cosine functions, inverse tangent functions, then the remaining inverse circular function, that is the reciprocals of the sine, that is the cosecant, the reciprocal of cosine, and that is secant, the reciprocal of tan, and that is cotangent. We'll be looking at the inverse of all, and trust me, you will have it. Then we move on to the last part to look at the inverse function values, how to find the exact value of the inverse function. Alright, so don't also forget that we first discussed inverse function in our previous section. We give a quick review here for a pair of inverse functions of f and f inverse. Alright, so this is the function f and this is the inverse of what? F. Very good. Now, I would like you to take note of these things. Jot them down. Jot them down. The first review is that 1. You have to know that if a function f is 1 to 1, then f has an inverse function, f inverse. We are saying that if a function f is 1 to 1, then f has an inverse function. Then f has an inverse function. 2. In a 1 to 1 function, each s value corresponds to only one y value. In 1 to 1 function, each s value corresponds to only one y value, and each y value, like is vice versa, and each y value corresponds to only one s value. So that is how it is. In a 1 to 1 function, each s value corresponds to only one y value, and each y value corresponds to only one s value. Beautiful. Alright, so that is the second part. Thirdly, point 3 to jot down. Alright, let's go. The domain of f is the range of f inverse. The domain of f, if I say f inverse, just write this one. The domain of f is the range of f inverse. And the range of f is the domain of f inverse. Very good. 4. The graph of f and f inverse are reflections of each other about the line y. Is very important, about the line y is equal to x. So the point 4 is saying that the graph of f, that is cosine, sine, and the others, we are done with those parts. The graph of those f and f inverse are reflections of each other about the line y is equal to x. Very good. And I will demonstrate to you what this means. The fifth part. To find f inverse of x from f, to find f inverse of x from f, you follow these steps. So to find f inverse from f, the first step you follow is that when So that's the point A. So that's the point 5. Let's come to the A. The points are under it. So the step 1, which is the A, you replace f of x with y and interchange s and y. And interchange s and y. 2, which is B. B, solve for y. Solve for y. C, replace y with f inverse. Replace y with f inverse. And that is the C part. And that is all. So in the remainder of this, then we use this fact to develop the inverse circular functions. The inverse circular functions. So we are now going to start with the whole thing. Alright? We are now going to start with the whole thing. So let's first start it from, okay. So let's first start it from inverse sine function. Then we move to inverse cosine function and the rest. Alright, now don't focus on the board for now. Please, before we start everything, I would like to give you these points. That is, what makes a function, or what is the criterion that we use to define a function to be an inverse. Alright, so now let's write inverse function. So for a function to have an inverse, one, the function must be one-to-one. The function must be one-to-one. This criterion is very, very, very important. One, the function must be one-to-one. Two, in a one-to-one function, each x value corresponds to one y value and vice versa. Very good. Three, the domain of f is the range of f of s. The domain of f is the range of f inverse and vice versa. 4, the graph of f and f inverse are reflections of each other about y is equal to. Oh, that's really long. Alright, so we look at inverse sine function, and inverse sine function, you can write it as y is equal to sine inverse of s, or arc sine s. Whether arc sine s or y is equal to sine inverse. Very good. Now, I gave you some steps of how to find f inverse from f of s algebraically. So that one, the first thing is that if you have y to be equal to sine s, and you want to get the inverse from it, the first thing is to replace f of s with y and interchange s and y. So f of s is equal to sine s. Then you move on again. When you see y, put s there. Sine. When you see s, put y there. Then you solve for y. So how will you solve for y here? That is taking sine inverse on both sides. So you get sine inverse of s to be equal to y. Therefore, y is equal to sine inverse, and that is what we have here. Or arc sine x. Very good. So, but this is the algebraic way. Let's look at it in the geometric way. So for the geometric approach, we have this diagram. This diagram is the diagram of y is equal to sine x. And that is what we have there, and you are used to how to get it already. Very good. So let me move straight to the point. Alright. So we are going to use the idea of this to get sine inverse. But please don't forget that what is the criterion for a function to be, for a function to have an inverse? For a function to have an inverse, it must be one-to-one. The function must be what? One-to-one function. So first, is this function one-to-one function? Exactly not. So for this to be one-to-one function, then we need to restrict it. How we know one-to-one function? For instance, let me demonstrate something small to you. Show you. Look at this graph. The graph of y is equal to x squared. This, can we say this is a one-to-one function? Can we say that this is a one-to-one function? Now watch. When you draw a straight line here, it cuts 2 points. It cuts 2 points. So this fails to be a one-to-one function. If this fails to be a one function, this will fail to be a one function. But let's look at this. Y is equal to x to the power 3. That one is like this. That one is something like this. And when you draw a line through it, it cuts only 1 point. It cuts only 1 point. So we can say that this one is one-to-one function. Alright? And because it's like this. Let's take it like this. Okay? A, B, C, E, F, G. So one-to-one. When this maps to this, it can map to another number here also. But it should map, a new number should map to another number here. Then this one will map to this. So this we call it one-to-one function. But here you can see that the y, when you put x to be equal to the number here, let's say the number a here. The number a here will give you a y value. Let's say this value here is f. If you put a inside the function, you get f. In the same way, if here is b and you put b inside of the function, you still get the same f again. That means that it fails to be a one-to-one function. So simply, when it cuts 2 points on the curve, that fails to be a one-to-one function. I hope you are getting the idea. Very, 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 very. So that is that. So this one, you get a different value, different value, different value, different value. And any linear equation too will be a one-to-one function. Because we know a linear equation to be, I said linear equation. Yeah, linear equation to be in this way. So this one too will be what? One-to-one function. Alright. So that is the idea of a one-to-one function. And you can see that the graph of cosine, the graph of sine is not a one-to-one function because this you get more than even 2 cuts or 2 points. So that is not one-to-one function. But for it to be one-to-one function, from what I just demonstrated, you can see that then there should be a restriction. We need to restrict it here and restrict it here. Alright? We need to restrict it here and here so that this will be a one-to-one function. So Now the domain of this will now be pi over 2 and 1. And here will be negative pi over 2 and negative 1. And the range will now be, okay, so this is the curve. Alright. So the domain for this, will be within negative pi over 2 and pi over 2. For it to be 1 to 1, then the range, I hope you're watching, and the range will be negative 1 and 1 to 1. If we assume it to be in this way, then we get a 1-to-1 function. Alright, I hope you are watching. But it doesn't. Okay. So then we get a 1-to-1 function. So now let's now transform into an inverse function. Let's now transform into an inverse function. But don't forget, the point 3 I gave you. Was it point 3? Let me go and check if it's point 3. That's, oh sure, point 4 rather. The graph of F and F inverse are reflections of each other. They are reflections of each one other. About the line y is equal to what? X. So this means that there is going to be a reflection here. I'm coming. So there is going to be a reflection where S will be equal to what? Y. Where S will be equal to Y. What this means is that the domain of cosine function here is now going to be the range. And the range of cosine function here is now going to be the domain. So the domain here will be negative 1 and 1. And the range will be negative pi on 2 over pi on 2. That is the inverse sine function. So we now get negative 1 and 1 here instead of negative pi on 2 and pi. Then here will be pi over 2. Then here will be negative pi over 2. Hope you are getting it. Very good. And the sketch is going to be this way. That is like that. So there will be one point here. There will be another point here. So that is going to be like this. It's not nice, eh? Please, let's take it like that. It's about getting the concept. Eh? Very good. So now you can see that this 1 to 1. Just one card, just one card. So this 1 to 1 function. I love this. This just 1 to 1 function. So that is how it's going to be. Alright, so now we have our new domain for the inverse, and that for this one is different. Very good. But don't forget, the y-axis will maintain y-axis, the s-axis will maintain the s-axis. Just that the domain and the range will change. Is that clear? Very good. Very good. So now, let me show you how the table is going to be. In case you can't remember, the table for a sine function, the table for this is is done in this way. We have y here, then we will have no. We have x and then we will have y here. Alright. And alright, yeah. We have x and then we are going to have y here. So with this, then we start with negative pi on 2. Then we are going to have negative pi on 4. Then we get 0 here. Then we get pi on 2. We are making an interval of 45 degrees, so we don't worry. That's it. So we do 45, then pi on 2, that's all. Let's end it here. No, here is pi on 4. Very good. Then this will give you negative 1. Yes, for sin s. So sin s of negative is punch on the paper, you get negative 1. Here you get negative square root of 2 over 2. Here you get 0. Then here you get, sorry, square root of 2 over 2. I don't have the calculator here, square root of 2 over 2. Then here you get that to be 1. So this is for y is equal to sin s. Now, for sin inverse, since we are saying that the y will maintain, the s will maintain, but the values will just change. This means that for the graph, instead of writing negative 1 here, here will become negative pi on 2, here will become negative 1. If you like, try and see. Try to punch sin inverse of negative 1, you get negative pi on 2 to be the y value or the output. And here also, here will now be negative square root of 2 over 2, and here will become pi on 2, pi on 4 right now. Here 0, 0, the same thing. Here you get square root of 2 over 2. Then here you get pi over 4. Alright. Here will become 1. Here will become pi on 2. So that is how the graph is also, the table is also going to be. Very good. So now, that is y is equal to sin inverse of x, or arc sin x. Let's proceed to the properties. So let's go look at the properties. The properties. We are going to write about 3 properties. So let's look at the properties. 1. The properties. 1. Are you ready? I will write one. The inverse time function is increasing and continuous on its domain. The inverse sine function is increasing and continuous on its domain, and the domain is negative 1, 1. 2. Its x-intercept is 0 and y-intercept is 0. So you see that the x-intercept is 0 and the y-intercept is also 0. 3. Its graph is symmetric with respect to the origin. Therefore, it is an odd function. Well, thank you. And that is all that I have for you under inverse sine function. So we will now move on to the cosine function. Alright, for inverse cosine function, it is cos inverse of x, or arc cos x. Very good. So looking at what we have here, you can see that the point here is going to be here, that is here, that is here, that is here, and that. Very good. So that is, this is y is equal to cos x. And we are going to get that on the inverse here. So let me do that. Still the same thing. For a function to have an inverse, it must be one-to-one function. It's what is, sorry, it's one there one-to-one function. That is not more than one kind. So for it to be one-to-one, then we need to restrict it here. When we restrict it here, it will still not be one-to-one. So we restrict it here. So here is 0, 1. Then we restrict this one to here. Oh, here will not help us because here there is going to be more than one cat. So therefore, we restrict it at pi. I hope you can see that. Very good. I want you to get the understanding, the concept. And this is pi negative 1. So you can see that the domain for cosine is, alright. For it to be one-to-one, we need to restrict the domain from 0 to pi, from 0 to pi, from 0 to pi. And the range, what is R, also from -1 to 1. So when we restrict the domain from 0 to pi, not 3 pi or 2, but rather pi, we can get the one-to-one function. Then we now transform it back here to get the inverse. Alright. So for the inverse, the domain for the range for cosine now change to become a domain here. So the domain will be this. Then the range for cosine inverse is going to be the range, the range is going to be the domain here. So the domain is 0 pi. So you don't need to choose this. If you know how the graph is, you can get it. It's not difficult. The domain and the range is not difficult, right? Know that one-to-one means that you cannot have more than 2 cards. That's all. If at the moment you write them out, you know that that is that. So simply let's now transform it. So you can see that the negative side, this one end here, this one end here. So the negative side don't come in here for the inverse. The negative side don't come in here for the inverse. And when you try to count that, you get only 5. Very good. So now, 0. Okay, so that is 1. Then here, we are going to get only positive. Pi over 2. Pi is n there. And that is what we are going to get. This one even don't come in. So here we are going to get, it's like this. It's going to be like this. So, alright. So here to be -1. Yeah, that's what I was thinking. So we start it from here, then here. And we are going to get it. Take it as such. So that's how it's going to be. Let me increase it more so that I can get a nice sketch for you. So the point here will be negative 1 pi. The point here will be 1, 0. Alright, so that is going to be that. That's going to be that. And we have several points within here, and we have several points within here. And you see, this is the x axis, this is the y axis. Now let me get you understand this more. Y is equal to cos inverse of x. For cos inverse of 2, you get undefined. Cos inverse of 3, you get undefined. Cos inverse of 4. Now, it's only the values here. For instance, half. You can get cos inverse of half. You can get cos inverse of half. You can get cos inverse of square root of 2 over 2. You can get cos inverse of square root of 3 over 2 and all that. But for you to get cos inverse of from 1 going, you will not get it. Right? You are going to get undefined for that. And we will discover that in our next, when we are solving for the value. So that is all for that. That is all for that. So you can see that here we can have half here. We can also get square root of 2 over 2 here. We can also get square root of 2 over 2 here. We can also get square root of 3 over 2 also here. So for this, for half, the y or the output will give you pi over 3. And for this, square root of 2 over 2, the output will give you pi over 4. And for square root of 3 over 2, the output will give you pi over 6. And the values here also, negative half. You can get, or you can find cos inverse of negative half. But you can't get cos inverse of negative 2. Those values will be giving you undefined. Very good. So that is that for that. Let's look at finding inverse cosine values. Oh, sorry, before we even go for that, let me give you the properties. Properties for the cosine inverse. 1, right, 1. The inverse cosine function is decreasing and continuous on its domain, negative 1 and 1. Don't forget, that for sine is increasing and continuous on its domain. But with this, we are saying that it is decreasing. You can see that it is decreasing. Alright, so, but for the cosine, for the sine, it was like this. So that is increasing, but this is decreasing. This is decreasing. This is decreasing. Alright. Are you done with it? 2. 8s intercept is 1. 8s intercept is 1. And 8y intercept. Don't forget, the s-intercept for sine inverse is 0, and the y-intercept is 0. But with this, you can see that the s-intercept is 1, and the y-intercept will be pi on 2. Very good. So from the graph, you can see it. S-intercept 1, y-intercept pi on 2. Last one. Its graph is not symmetric, which respects the graph is not symmetric with respect to the y-axis or the origin. And since it's not as respect to the origin, it will not be it will not be even, it will not be odd function, but rather an even function. So this is an even function. Alright. So this is going to be a given function. Let's now move quickly to inverse tangent function. Alright, so that's inverse tangent function. So the value for that of y is equal to tan x, the values will now interchange. So that is that. Now for y is equal to tan x, it was something like this. It was something in this way. It's going in this way. How we can see that? So for this one too, sorry, it was like this. Okay. Now, and the domain was on negative pi. The domain was on negative pi on 2 and pi on 2. And the graph was asymptotic also. So it is the asymptotic. Alright, very good. Very good. And it has no range also. It has no range. So that is for the y is equal to tan x. But when we come to tan inverse or arctan x, for that one, it will now turn this way, okay? It will now turn this way. So this is how we are going to get it. So the domain for the inverse, the domain, we can see that it has no domain. So the domain will be negative infinity to what? Positive what? Infinity. And the range will now be negative pi on 2 and pi on 2. Alright, so that's going to be that for the arctangent or tan inverse function. Very good. So let's quickly move on to the properties and proceed to look at the values, how to find the values for all. That's cosine inverse, tan inverse, and sine inverse. We will take that to a new video. So now, let's look at the properties. One, the inverse tangent function is increasing and continuous on its domain. Increasing and continuous on its domain. And that is the domain. 2. Its s-intercept is, what is that? 0. So its s-intercept is 0 and its y-intercept is also 0. 3.3. The graph is symmetric with respect to the origin. Yes. The graph, you can see all that. Okay, you can see all that now. The graph is symmetric with respect to the origin. And if it's respect to the origin, therefore it is an odd function. Lastly, the line y is equal to pi on 2. The line y is equal to pi on 2 and y is equal to negative pi on 2. This are horizontal asymptotes. So these are the horizontal asymptotes. So for the inverse tangent function, we have a horizontal asymptote, and that's for the function of tan. There is a vertical asymptote. But since it's now turning this way, it now becomes a horizontal asymptote. Very good. So that is all for that. Now, let's look at, before we go to the values, or let's take that to the values. Okay. So let's look at the remaining inverse circular function. For the remaining inverse circular function, that is the reciprocal. Okay, for sine, cotangent, for sine, the reciprocal for cos, the reciprocal of tan. So we have what? Cosec, secant, and cotangent. Alright, for that one, we can show to you graphically, but let me give you the domain, the range, and the interval, and the current, and everything. Okay, let me give it to you in the table form for us to proceed for that. For that one, we're not going to look at it in the geometrical way. Okay, so now let's first look at finding the inverse sine value. Finding the inverse sine value. So the first one we are going to look at it is y is equal to y is equal to arc sine 1 over 2. And we know that that is the same as very good. So now watch and look at the steps I'm going to take you through. So you can just punch this on calculator and get your results. That one is there. Okay. You can do that and you get your results. But let's see how to go by it. So first of all, let's take, you know the steps already. First of all, okay. So the first thing is to replace f of x with y. And the second step is to solve for y and all that. Very good. So now let's go. When you take sine of both sides, you get sine y to be equal to 1 over 2. When you take sine of both sides, you're going to get sine y to be equal to 1 over 2. Now you know that sine is y over x. That is the opposite over the adjacent. That is opposite over the adjacent. Very good. So when you sketch this, one is here, alright, so now take your calculator and let's go. Sine inverse of 1 over 2. You can see that sine inverse is not on your calculator, but you can check it there. Where we have sine inverse also there. Alright, but you need to first press on shift and that shift sign and you get the sine inverse. Then you press sine inverse of half and that's going to give you pi on 6. And that's going to give you pi on 6. Very good. 2. We have y is equal to sine inverse of negative 1. In the same way, shift sign, you will see the sine inverse. And that one to you get y to be equal to pi on 6. I on 6. 3. And unfortunately, let's look at y is equal to sine inverse of negative 2. Now you can see that when you put on sine inverse of negative 2, you get, sometimes you see it to be syntax error, sometimes you see it math error. Now what this means is that on the graph, go back to the graph and see, you can see that this does not exist because negative 2 does not in the domain of sine function. This is not in the domain of what? A sine inverse function. Since the domain is only 1, negative 1 and 1. So it only values within this range. Or yeah, it's only values within this that you can find the inverse of it. But for negative 2, negative 3 and the others, you can't. So you just conclude that does not exist. This does not exist. This does not exist because negative 2 does not in the domain of sine function. Very good. Let's quickly move on to, all right. Okay, let's look at finding the inverse cosine value. Finding the inverse cosine value. So the first one is y is equal to cos inverse of 1. And you know that with this is the same as arc cos. Arc. So this one is going to be a arc cos. So the C will double arc cos 1. And this shift cos, the same thing, shift cos. You are going to get that to be 0. We're going to get that to be 0. Alright. 2 y is equal to cos inverse of square root of 2 over 2. And with this also, when you want your calculator, you get, you see this one is still within the domain, it's still within the domain. If you go above the domain, you get mass error. And this one, quickly, 3 pi over 2. So that's going to be the result for that. Very good. Let's see how to find the values also for. Let's go for that of tan. Oh, okay, that's all. That's all. Now let's move to the next video. In the next video, we are going to look at finding function value using the definition of trigonometric functions. Finding function values using the definition of trigonometric functions. Now, in case you have a tan inverse, for instance, tan inverse of 3 over 2. In the same way, do it the same thing, shift tan, and the results will come. Very good. So, see you in that video to look at finding function value using the definition of